Hello everybody, welcome to today's video, and today we're going to be graphing quadratic equations completely in the calculator, and then we're going to be labeling the same things that we're used to labeling, but the new part for today's lesson is we're also going to be labeling the domain and the range. I hope you remember domain and range because they're super easy things, so today should be a pretty easy lesson since everything's going to be done in the calculator. I'm going to go ahead and use a calculator app that was available in the Apple Store. This one is called Calculator X. It's not the best calculator, but it is pretty much the same thing as that calculator that's in your Chromebooks. But I prefer using my iPad to record so that way I can get the best quality of screenwriting and video editing. Okay, so let's get started. We have our first equation for question A is f of x equals negative x squared plus 1. I'm looking over here at the left side. F of x equals negative x squared plus 1. That's going to be the first equation we type in. Remember, the first thing you push is y equals. That note is even written here at the top of the paper. Then, if there's something in there, you should delete it by pushing the clear button. But I actually already typed this one ahead of time, so I have negative x squared plus 1 written for y1. I'm going to go ahead and graph it just so that way I have a picture, an idea of what's going to show up. It looks like I have an upside down parabola, but this calculator app doesn't have any numbers on it. So let me see if I can open up the table for that. Second graph opens up the table. I'm going to be adding the points to my graph on the left as I read these numbers. 0 goes with 1. Negative 1 goes with 0. 1 goes with 0. It looks like the graph is centered around the y-axis, which means that the axis of symmetry is going right through the y-axis, which is right through here, which means that that axis of symmetry is happening whenever x is equal to 0. The vertex. The vertex is either the minimum or the maximum of the graph. Let me just add a couple more points. Let me put negative 2, negative 3, and let me also add 2, negative 3. If I connect these dots, then it's pretty obvious to see that the graph is opening downwards, which means that the vertex is at that top point, which is at 0, 1, which makes it a maximum. The solution, which are the same thing as the x-intercepts, are going to be at negative 1, 0, and also 1, 0. The domain. The domain is measuring from left to right. From left to right. How far does this graph go to the left? If this graph is going to keep on going down and to the left and down and to the left forever, then does it have an end point? No, it's just going to keep on going down and to the left. So if it's going to keep on going to the left, then it's going to keep on going until it reaches, well, it's never going to reach it, but it's going to keep on going until or up to negative infinity, never ending. Since it's never ending, we are always going to be x's that are greater than that. And if we look on the right side, we are going down and to the right forever. And since we're going down and to the right forever, that means that the maximum would be infinity, but we won't reach it, so we are always going to be less than infinity. Look at the range. The range goes from up and down, from top to bottom. What is the lowest that this graph reaches? If you see this arrow, it's going to keep on going down and to the left. It's going to keep going down and to the left. And if it keeps going down forever, then it's going to go down to, or close to, negative infinity. It's not going to reach there, so it's always going to be greater than. The y's are on the bigger side because the y's are bigger than negative infinity. But the y's also have a maximum. The maximum y is this one right here. No y's on this parabola are higher. None of them are greater than positive 1. Positive 1 was the maximum y, which was in the vertex. Okay, first one's done. Let's go to the next one. We're going to do the same thing. And if you want to, you can just go ahead and do the next two on your own. You're just going to put them in calculator, open up the table, graph the points, label these key features. But if you want to watch the video, I'm going to have it going at 2 times speed of me doing it. Okay, I got the second one done. And I'm not going to show you the third one. The third one I expect you to be able to do. Something I noticed while doing the second one was that whenever the y for the range is being bound, the boundary is that -4. If you look at the graph, -4 does get plugged in and it is a solution. It does reach that -4 for the y. Because it reaches that -4, it's important that you include that it's less than or equal to it. Or sorry, greater than or equal to it. And over here, you also need to have this one saying that it's or equal to for that 1. Because that 1 is the maximum, so everything is smaller than or equal to that 1. And this -4 is the minimum, so everything is larger than or equal to that -4. Okay, now let's graph the vertex form in the calculator. It won't be that bad. The only difference is we'll have to use some parentheses, and that's it. All right, so let's do -1/3 x. Let's push the y equals, clear it out. The negative button. To do 1/3, I would just put 1 divided by 3 inside of a parentheses. Then that 1/3 is going to multiply. In fact, if you wanted to, you could put that negative sign in there too. That's a -1/3 times x plus 1, close it, squared plus 3. Let's graph it just to get an idea. It's going to be a parabola that opens downwards. Now let's open up the table. And let's see, I like to center my table around whenever the numbers start repeating. So I look at the y's and then I scroll up or down to see when am I seeing the same number on top that I am seeing below. And if I scroll it right here, you can see that I have 1.6 at the top of my table and I have 1.6 at the bottom of my table. So that's showing me that the graph is going to be centered around that middle number, which is at -1,3. So -1,3 will be the vertex. It's going to be the center of the parabola. From there, if I go left 1 space to -2, I'll be at 2.6. -2 is at 2.6. 0 will be at 2.6 also. And then the number 1 will be at 1.6. Which means that if I moved to the left 1 more space, I would still be at 1.6. So that I make sure that I get this thing wide enough, I'm going to go ahead and get that next point, 2, 0 on the right side, which means that if I go 1 more to the left, I'll be at 0 this side too. So now I have a pretty good shape for my parabola. Alright, we can see that we're centered at -1 for x, 3 for y. The axis of symmetry is going to go through the x number for the vertex, which is -1. The solutions, good thing I added those last points on the graph, because those solutions are at -4, 0, and also at 2, 0. You don't have to, but it's probably good practice to write your solutions in order from least to greatest. So like the one that's on the left, and then write the one that's on the right. The domain. From left to right, is there anything stopping this graph? Is there anything that's going to stop this arrow from going to the left? I don't think so. And I also don't think that there's anything stopping the arrow from going to the right. So it seems like whenever you're graphing quadratics, the domain is almost always going to be from negative infinity for x and positive infinity as the maximum for x. The only time that would change is if you're doing a real world question or if you're doing some sort of word problem that has a specific boundary. But if we're just graphing quadratics per equations and there's no situation to go with it, then this is always going to be the domain. And the range, though, that does have a difference because we're always having these vertexes, and the vertex is always going to have that y show up in the range. So this vertex has a maximum because the graph is opening downwards. So that max y is at 3, and every other y is going to be less than that. And the lower boundary is going to be a negative infinity. Since we can get to that 3, I'm going to have to put that less than or equal to in between those two things. Okay, I think you should be able to do this next one on your own pretty easily. Let's see the third one. Yeah, it should be fine. So just make sure whenever you're typing in your equation, throw in the parentheses, and then when you're looking at the table, scroll around on that table until you find where the numbers have a center, where the numbers repeat. If I go to that -6, then it gives me the +4 for y, and if I look at the -2 for x, it gives me the +4 for y. So those numbers are repeating, which means that right in the middle of those numbers is going to be the center, which is at -4. Once you find that center, you start graphing to the left and to the right of that vertex, and then it should be pretty easy to get the picture.